In this video, we're going to look at the fact that group homomorphisms send identities to identities. In other words, we're going to prove the following theorem. We're going to let G and H be groups, and F is going to be a group homomorphism from G to H. Then it turns out that F sends the group identity in G to the group identity in H. So the way we're going to go about proving this is we're going to start with an arbitrary element in G. So little g is just any old guy in G. So what we know is that G is equal to the group identity in group G times little g. And what that's going to imply is that f of g has to be f of eg f of eg times f of g, and this is because f is a group homomorphism. Now, what I want to notice is that this particular element here, he lives inside group H. In other words, I'm going to make a note that there exists an H inside capital H such that f of g is equal to little h. So what we now have is that f of g equals f of e sub capital G times f of g implies that h is equal to f of e sub capital G times h. And what that lets me do is post multiply by h inverse. So we have h times h inverse is equal to this ugly element times h inverse. But what that's going to say is that we have the identity element in group H is equal to this lovely guy times the identity element in group H. But that means we wind up having E sub capital H is indeed f of E sub g, and we're done.